but it has been pushed back a little bit. But the study guide is available, and I advise you definitely to take advantage of that and to. Oh, someone just started the recording for me. Did I not start the recording?
Nope, I got it.
Good. Thanks. Awesome. So anyway, midterm study guide is available on Canvas, and also as an announcement. So take advantage of that. That's worth a lot of points and definitely has a big impact on your grade. The prototype and project description is due today at midnight. And then on Friday, the 27th, the quiz is due, and that is also due by midnight. And you take that online at your leisure. And I actually have taken off the password, so it's not password protected, so you can take it at any time you want before midnight on Friday.
Quick question.
Yes.
Does that mean that we can take it anytime between now and then?
Yes, that's correct.
Okay, great.
Yeah. Good question. Yeah. So again,
are we actually gonna have class on Friday as well, or is
yes,
it just the? Okay.
We will have class on Friday as well. So that was Ian, right?
Yes.
Okay. So yeah, we will have class on Friday as well. Might be shortened a little bit. That way you give you some time to work on the quiz if you are so inclined. So we'll see how that goes. And then on Friday, March 27th, the required specification for your project team is also due. Again, keep in mind that that is a sort of, you can think of it as a rough draft, your first cut at your software requirements, because you are allowed for that assignment and the design assignment to keep resubmitting it as you get comments from me or think of any improvements that you can make to your requirements. So that's our elevator design problem, but I am going to now flip to finish up our testing and quality assurance, which was slide 24 is what I have down. So okay, so let's bring up Teams. Okay, so do you see the software inspections slide?
Yes.
Good. All right. So this is where we left off. We going back one slide, we talked about inspections and review as a valuable tool for creating defects in the first place and working out testing. So basically, the steps outlined in our text for a design review is planning, overview, preparation, inspection, rework, and follow-up. So basically, you're planning for what you're going to be testing with your inspections. You have an overview of exactly what it is that you're testing so that everyone sees it. Preparation, which includes getting the material out to the people that are reviewing your artifact, and then doing the inspection. Rework based on the inspection, which basically the inspection will end up with a set of to-do items, basically assigning them to people as action items. And then the rework based on the action items, and then follow up that those things have been done. They should be focused on finding defects. And again, I pointed out, or my philosophy is that management should not be involved because this should not be an evaluation of the person who did the work. It is focused specifically on finding defects and not evaluating performance. The output is a list of defects, and again, I said action items, and so some of the defects will be action. I mean, some of the action items will be specific defects, but sometimes there could be other action items that result. Team, generally, you want 3 to 6 people. Author is included, and then you generally assign, like I said earlier, roles. Specific roles are the moderator and the reader. Generally, the moderator and the reader will be the author, but you can assign different people to do it, especially if it's contentious. And then a scribe, which is the person who's taking the meeting minutes. And the presenter is, like I said, generally the author. So here's something regarding inspection versus testing. According to the text, it says it's partially cost effective. I would say that it's very cost effective because not only are we getting good testing or removal of defects from this at an early stage, but there are other benefits as well, and you'll see that here. It can be applied to intermediate artifacts, so it's not just the software, but things before, so it could be early in the process, so therefore it does catch defects early. And then it helps disseminate knowledge about the project and best practices. So it is an opportunity for other members of the team to see what's going on in other parts of the project, which does fulfill the purpose of having cross-training, so that if someone leaves the team for whatever reason, that other people in the team do know about that area of the project. Testing in general can find errors cheaper, but correcting them is expensive because it happens so much later in the process. Design reviews will catch it in general earlier. It can be applied to code, but the testing can only be applied to code, but inspections can be applied to earlier artifacts like design and requirements. And again, it has the situation where the defects are caught later after implementation, but it is necessary to gauge the quality of the product and used for determining whether the product is ready for release or still needs more work to before releasing. Other techniques is formal methods. There are mathematical techniques to use to prove that a program works. Used for requirements, design, algorithm specification. It can actually prove that the implementation conforms to the spec. And then also that it conforms to the pre and post conditions. But the problems is it requires math training and it's very complicated. It's not applicable to all programs, and it only provides verification, not validation. And large portions of the program, like the user interface, or how well the software is written with maintainability in mind, are not covered. And it is a very small category of software that you can use formal methods or mathematical techniques to prove and verify software. So it has limited use. Static analysis. Static analysis is something that you will most inevitably use. It's examining of static structures for error-prone conditions, and also it will do measures of coupling and cohesion to give you ideas about areas that may be susceptible for errors or be problems in the maintenance phase that you will constantly be fixing and correcting areas in that particular piece of code. So there are automatic tools that are used. It's not done by hand, and it applies to intermediate documents, source code, and executable files. But the key thing here is that the output needs to be checked by a programmer. There will be false positive where they'll say the tool will say that this is problematic code, but sometimes that code is purposely done that way for a reason with by a conscious effort of the developers and the team. And so there is the possibility of false positives. So the output does need to be checked by the programmer. You can't just use the changes blindly. So that is the quality assurance chapter 10. I'm going to just go through quickly some of the slides to make sure that all the areas of quiz material is covered and emphasized. So first, for this testing, the main purpose of testing is finding defects and assessing and ensuring quality. So the main purpose of testing is finding defects and assessing and ensuring quality, something to keep in mind for what the purpose of testing is. Key thing here on this slide is the difference between verification and validation testing. What exactly is verification testing and what is validation testing, and what is the differences and the purposes, different purposes for each of these. So who tests? Key here is that it's not just the developers and it's not just SQA, but it is lots of different people. It's the programmers, the testers, and users, and this is probably a more a limited definition of, because there may be other people involved as well. For instance, my service department, every once in a while, I would bring them in on testing because they're working directly with customers and they have unique insight into what needs to be done. So they actually turn out to be very valuable testers. So it's not just SQA but there are multiple categories of people that are involved with testing. So here we have the different types of testing, and key thing to pull away from here is what are we testing? And performance testing, again, is looking at the behavior of the code and whether it addresses the performance requirements that were outlined so that we know that the software will happen in a timely fashion. So it is important to know that, and that stress testing is a way that we use to assess whether the performance is adequate. Now, like I mentioned, I think in an earlier class, we had a situation where we had some automated test software that our software quality assurance team did, and they had it so that they were clicking on a button 500 times in a second, and we decided that was probably not reasonable. So definitely you do it with your actual customers in mind. White box testing is testing using the requirements and the source code, whereas black box testing is only the requirements and design. It is not using the actual source code. So again, white box testing involves the requirements and the source code, and the key is that you're using source code as well as everything else. So here, make sure you understand what is important in constructing test case. We know from experience that boundary conditions, both at the boundaries, inside the boundaries, and outside the boundaries, should be covered with test case to have good coverage. And then key thing with path analysis is that branch coverage would ensure total coverage of it if you were able to do it, but it's seldom practically achievable because the number of logical paths grow or exponentially. So it is not possible to do all coverage. So you usually have a percentage, but so it is not, it's seldom practical to have 100% coverage with all paths. And for this slide on unit test, make sure you understand why it is done, and keep in mind it is easier to locate errors when they first arise, and unit tests are a valuable tool in doing that, in that you're detecting the errors right after you've written the code, so that you know specifically what code is involved. Now, it is possible that it is a related class or some class that you're using, so it is not guaranteed that it is in the code that you just wrote, but it's something associated with the code you just wrote. So that is a valuable tool for unit testing. Please note that this does not guarantee that the code will be free of defects. You can always miss various situations or conditions in your unit tests, and the testing and the coverage is only as good as your unit tests are. So it is not a guarantee. Test-driven development, again, very popular with extreme programming, and that's where you write the test ahead of time before you actually do anything else, before you do the implementation. Key thing here is we use static analysis to look at programming style or error-prone programming practice, such as excessive structural complexity. Also, we use an automatic static analysis tool in most cases. It's the way that's done. It makes it cost effective, but we do have to be cognizant that false positives are possible. So that does have to be checked by the programmer. So basically that is the coverage of testing. So let's move on to UML design.
I believe you're muted, Mr. Lim.
Yeah, Mr. Lim,
Indeed.
you're muted.
So it turns out that only the people who unmuted me themselves would hear me. So can you hear me now, Ethan?
Yeah, we can hear you now. Well, I can.
Yep,
I
good.
can hear you.
Let's see. Okay, Ethan.
You're muted again.
Yeah, and I'm not able to unmute. It doesn't look like it's on the client end.
Me
Okay.
neither. There we go.
So it's interesting. As I'm scrolling on that window, it appears to be muting myself. I have to be careful of that. Okay, so now.
Hey, look, a software defect.
Yes. There you go. We have some a error detected in the field. So let's see. Can everyone see the UML class diagram in front of you?
Yes.
I can see it.
Good. So I just I did the boring thing or the straightforward thing, and went in alphabetical order, which put the Dalton brothers first because they are first in the alphabet in last name for our class. So this is Caden's class diagram. So Caden, would you be willing to jump in and explain your class diagram here if you have a microphone? Let's see.
I don't see mine opened. Did you just not open it yet?
Oh, yeah, I haven't opened it yet. Is that
Okay? Gotcha.
Who is that? That's
It's Gabe.
Gabe. Yes. No. I have not. I'm just basically going alphabetically by last name through right
Okay,
now.
gotcha.
So.
Because I see those 5, but none of those are my file name.
Oh, the 5 where that are uploaded in Canvas or
No,
what?
the 5 that are the 5 tabs that you have open in your Adobe
Oh,
Acrobat.
Yes, I have not opened all of them yet.
Okay.
Yes, that is correct. I just did a couple of them to start out with. I have the folder open so that I can bring them up, but right now they're not all online. So Caden does not have a mic. All right. So would you be able to chat a few messages? So we're going via chat with Caden. So first of all, let me say this right up the front, right off the top. Caden, sorry. Caden, I'm very impressed with your submission. This was really well done. It really was. You're probably ahead of where a lot of my students were last year at the end of the semester. So this was really well done. So first of all, can you explain to us the relationship between the control panel and the button and how that is, what that means, I guess, how that is related? If you could do that via chat, that would be great, Caden. Okay, so basically we see here that Caden is saying that the button needs to have 2 types of existences, one for the shaft and one for the elevator. So by the shaft, are you talking about outside the door in on the floor? Is that what you mean by the shaft? Yes, outside the door. Okay. And then you can see here that he has methods involved with it. So for the button, it's you can have a functionality that turns on and off the light, and then another call that calls the elevator to the floor associated with the button. So he decided that the floor was not really relevant in terms of a class because it can be considered as an attribute to where are you storing the floors, Caden? Oh, instant array, yes, and that array would be stored where? In the driver, which is the building. Okay, good. So that's one way to handle it. Right. And so that also means the button will have an attribute, I would assume, if it's the floor button, that would be which floor am I, so that it would know what floor it's associated with. So I think that would be an attribute of the button is which floor is it associated with. You may have also an attribute whether it is a elevator button or a floor button, which could point to the fact that it could also be two separate classes or one, depending on how you want to handle it. We can see that he has the elevator panel and various operations that can happen to them, and the light, which is operation none, but I would assume that you would have something like, oh, so the button turns it on and off, and I would assume the light would have something similar. Okay, and I see your shaft panel, which is the floors, and then the library. What is the library associated with? And other members of the class chime in if you have questions about how the class diagram was meant to work.
So I have a quick question.
Yes.
So I remember that you said that we had to distinguish between like the top floor and the bottom floor in the sense that not all floors would have two buttons.
Right.
The bottom floor would only have an up button and the top floor would only have a down button.
Correct.
Is there something on here that?
Yes. How would? That's a good question. So Caden, how would you reflect that in your design here? So one possibility I can see here, let's see, we have that the control panel has, let's see, the buttons, and there is one button, one to many on the control panel. So there's many of them in the control panel. And I would assume that probably the button would have whether, let's see. Oh, and then we have the shaft. The shaft is the floor. So okay, so I see Caden just type, I think 1 versus 2 buttons is an implementation possibility. I would assume to just take off whichever button is not needed so it doesn't affect the design. So your buttons, certainly looks like your lights are associated with your shaft panel, and that's a floor, I assume. And you have 0 through 1. It actually would be 0 through 2, I believe, maybe. And that each panel would each floor would actually have whether it has a up button or a down button. And if for instance you're on the first floor, you would have that down button is false or null. that there would be no down button. And then the other floors like 2, 3, 4 would have up and down buttons, and then the top floor would have null for the top floor, or you could actually have a variable or an attribute that says how many buttons are associated with the shaft. So we have button and light. We see that here that Caden has separated out the concept of button and the light. Possibility as you go through the design is maybe the light and button are one and the same, or maybe not. Maybe there's advantages to having them separated out. So Caden, awesome. Good first cut. And then Caden has a state diagram. So here's his state diagram of his button. Now, in an overall design, you would actually do state diagrams for lots of the classes, but the fact that he has a state diagram for the button is great. So we see here that I believe the initial state is off. Is that correct, Caden? Is that how, am I reading this correctly? Yes. So you can see that black dot with the arrow pointing to the off. That's saying my initial state is off, and that's where we're going to start. And then the trigger event comes, and it will, if you're in the off state, it will send you to the on state. And if you're in the on state, I believe it will take you to the off state, but there is some trigger guard that keeps it in on. Caden, can you explain what you mean by that? Okay, so he says it's first time with a state diagram, but I think it's just a redundancy. So it actually might be incorrect because I believe as you click on the button, you would, oh, wait a minute. I see. If you're, this is a floor, if this is a floor button, you actually won't, if you click on the button, you won't necessarily go to the off state. In fact, I would say both for the floor and in the elevator, the state that goes from on to off would not happen. Oh, it's not labeled as trigger, so it's probably a different event, which is basically the elevator has reached the designated floor, and that would be the transition to off. And then this trigger guard, which goes from on to on, is actually correct. If you're on a floor and you click on, if you're at a floor, on the floor and click either up or down button and it's already on, it would stay on, it wouldn't go off. So that is correct, that it loops back to the same state. And inside the elevator, I think that would be the same case. If a floor number button has been pressed and it's on, if you click it again, it would stay on, it wouldn't go off. So this event below, the trigger guard going from on to off, I would assume then is a different event. It's not a trigger guard event, but it is an event that you've reached the requested floor, or if you're at a floor, that the elevator has arrived. So I would assume that would be the state that happens. And then Caden says, I think it happens simultaneously. And what is it that you're referring to as happening simultaneously? So Caden says it stays on the trigger guard, and turns on the light, then calls the elevator. So here we have light on and then call the elevator. So what I see here, and is a common situation with state diagrams, is that it starts becoming a flow chart, and it just seems to be a natural tendency that happens. So I would say this light on is pretty much integrated into this button, and that what you've done is actually, when you go to the on state, there is an action that happens that creates a signal to the light and tells the light to turn on. So that light on button is actually a state associated with the light, not with the button. So it actually is an action in the on state that sends a signal to the light and turns it on. And so now this light on state is actually associated, can't hardly talk, with the light, I would assume. So, and then the call elevator, again, is an action within the on state. When you click on that button, it will call the elevator. So again, that's an action that happens in the on state, not a actual state of the push button. So I would say your push button has the states on and off. These light on and call elevator are actually action items, and I'm guessing that maybe that's what you meant by the light blue color. Is that right, Caden? That you did realize it was something different. Right. So yeah, the light on and call elevator would be in your bubble on the on state. You would have a top header with on state being the title, and then below it a list of actions, which are send, turn on to the light, and tell the elevator, come to my floor, call elevator. Those would be actions that would be within the on bubble there in the state diagram as actions, that as soon as you enter that state, that's what happens. Yes, only off and on are the states. That's correct. So it looks like it's the design is correct. It's just a diagramming convention difference. So yeah, you would put the lights on and the call elevator actions to send the events to the elevator, and the light would be in the on state. Basically, you'd put a line at the top, which would be on, and then below it, below the line in the oval, would be the actions that happen for the state. Great. So that was very nice, Caden. Thank you. And then here we have, so he had an additional one. So here's his state diagram for the elevator. So the elevator is arrived is your initial state. Certainly it has arrived for a particular floor, and I guess it would be at a floor. That would be right. And then the trigger elevator call but Boolean check. So basically there's a trigger for the elevator, and then the elevator presumably would have to move, and it would be go to a state that says it hasn't arrived, which is correct. It has, because there's a new request. There would have to be some type of mechanism that would end the elevator, that would allocate which floor it's going to. But then you have another state that goes back, which is arrive, which I would assume is that shaft, which I call floor, but you called shaft, which says it would report back that the elevator has arrived at the right location, I believe. So that would give the arrive state. Then we have a loop that hasn't arrived. I'm not quite sure what that event that you're diagramming there is, Caden. If you could fill me in on that. The event. The event that goes from has arrived back to has arrived, that's called trigger elevator call Boolean check. Oh, that's just, he says that's just what he renamed the trigger guard. And so if a button has been pressed, it still hasn't arrived. Okay. And that is interesting. So one of the things with state diagrams is you have a list of different events that go around, that come around. And you can see here that the trigger elevator call event really doesn't have any result of changing the state. It stays and hasn't arrived. And there's two approaches to doing that. One is if you go back to the same state and has no impact on what happens, that you leave it off the diagram. And then the other is that you put every single event in your state diagram so that you know that you've checked it and you made a conscious decision what it's supposed to do. And generally, what I've seen is that you do something in between. On your first cut of your state diagrams, you handle every single event. And then once you've got it all ironed out, you do another state diagram that eliminates those events that have no impact, so that the diagram is not so cluttered, basically. You know, it is correct to have every single event and what happens there, but it would be cluttered if you put too many in. So we have a comment from Jason. A useful tip for those without mics, you can connect to the meeting from both the computer and phone at the same time and use the mic on the phone if needed. So yeah, if there's another key, is that you can use your phone and participate without a mic. So anyway, going forward with the design problem, Caden says, I'm assuming that these aren't automatic from the hasn't arrived state and that they are conditions. Okay. So that they're a conditional event, an event that happens. So that would be based on the elevator. That would be a condition in the elevator whether those events come in or not. So again, consistently we have here the add to the queue stack, which is, again, an event in the hasn't arrived state for the elevator. And the queue stack, I believe, would be associated with the controller. There's probably some ultimate class that's involved in managing that. And no, that's not the. So you may need to add a class, and I'm not sure if one of the classes here is meant to be that, like maybe the library. I'm not sure. But you also see here that Caden has nicely used the has or aggregates, the aggregation symbols to say that they've aggregated, and then we have the inheritance relationship of buttons and lights. I believe that's what's being modeled here, but those are things to keep in mind that are useful to add to a class diagram. And you also have, he has one-to-many relationships, so the cardinality of the relationship. And here he has 0 to 12 for the elevator, and I'm not sure what 0 to 3 was with the lights in the problem. But anyway. So anyway, great cut. Again, just for a diagramming thing, the add to stack queue and the move the elevator are actions that happen within the hasn't arrived state. Control panel, perhaps, yes, that was my first cut too. But is this the control panel that is in the elevator? Yeah, I guess it could be. It could be, but it has to have some type of interaction with the buttons on the floor as well. So you would have some kind of interaction with the buttons on the floor. But yeah, that would be a good place that it could be. So great. So let's move on to your brother. And so we have this. Oh, and McKenna, do you go by Mikey, or is that a nickname, or is that what you go by?
No, I don't go by that. It's just when it asked for my name, I didn't feel like typing my real name, so I just put it in something else.
But you now know that all your fellow students are going to start calling you Mikey now.
Yeah.
Yeah, Mikey. How's it going, Mikey?
Or Mickey, whichever one.
Yeah, right. Okay, so you can see here he has a nice class diagram with the door and the elevator, and he notes that there's a relationship. I would say that probably the elevator has a door, and probably the floor has a door as well, because we have to worry about opening and closing 2 sets of doors, or is it 1? Maybe it's 1. I guess it's 1 with the elevator. Yeah. It depends on if it's what kind of design the elevator has, because certainly we see the manually open door elevators as well. So so elevator has a door, and so what's the relationship between the floor and the elevator? So I see the arrows with the relationships, but I don't have actual names associated with them.
For the floor buttons?
Yes. So for all of them in the arrows, so we have the elevator between the arrow between the elevator and door, and I assume that's is a has relationship. So so actually it would be the I can't remember right off the top of my head. It would be I would say it would probably be the big triangle filled in would be what your arrow should be on the elevator for the door in terms of notation. But so then you have elevator has floor buttons. So again, that would be has a relationship. So you would say that the elevator consists of floor buttons. And you have buttons with floor buttons. Is that an inheritance relationship? Is that what is meant there?
I think so, because that is a description of the floor buttons.
Right.
So the floor buttons are labeled with ints, but then their functionality is going to be related to a Boolean.
Right. So I would say that that's probably should have been an inheritance diagram, which is an open triangle pointing at the button. That would show the inheritance relationship between the button and the floor button. And I do realize that part of this may be due to the tool you're using may not be as easily amenable to doing it. And then I also get a comment from Jason. He says that Adobe Acrobat is ruining people's display by displaying random text strings where they shouldn't be. Is that in terms of the diagrams here, Jason? Is that what you're referring to?
No, when you use anything except the official Adobe Acrobat, it just kind of fills in strings in places. Like most of the time, the document name just gets set as whoever the logged in user is. So whenever I open a document, it just displays the name as like Jason Laycock, no matter what I name the document.
Oh, I see. I see what you're saying. Okay.
I don't particularly like PDFs. They annoy me.
So there we go. Got a comment from Jason. Good to know. So, and then we have the up-down buttons, which also inherit for buttons. So again, that should be tied in with the open arrow pointing at the button to the up-down buttons. And the floor contains up-down buttons. Great. So, yeah, so we have some diagramming issue in terms of the syntax of the diagram. But again, I would say a pretty solid understanding of what the intent of a class diagram is. So very nice. And then just to finish this up, he has his class of elevator with the elevator button class. So, okay, so this is just further elaboration. So here, this looks somewhat like a flow chart. So I see the information that you're trying to convey here, McKinnon, but I think that this information that you're conveying here in the state diagram, or in the class diagram, sorry, the class diagram would most appropriately represented by a sequence diagram. So that is an area where you can get some more expertise, but this is valuable information. I see where you're going with this, but a sequence diagram would probably be the appropriate diagram to convey this information. So that takes us to the end of our class period. So do we have any questions? So nice job by both of you. And again, for those of you who submitted your UML diagrams, this will be extra credit for you. So these 5 points will be extra credit. And for those of you who didn't submit, go ahead and submit it before Friday, and we'll continue to look at some of these class diagrams and state diagrams. So any questions?
No.
Okay.
Mr. Lim, are the slides going to be posted online?
You mean the slides of the exercise with the class diagrams and the...
No, of the sorry, of the chapter 10 slides. I haven't looked, but I was just wondering.
They're already up.
Yeah,
Cool.
I think they were posted early on. I mean, before spring break even. So yes,
Gotcha.
those slides are available.
Okay, sounds good.
Yeah. Look in modules, and they're all listed there, as well as that's where our class recordings are ending up. So the class recordings are there. The chat window is not visible, but if you go into Microsoft Teams, you can actually see your chat windows. And so is anyone coming from the web? It looks like we're probably not getting anyone from the web anymore. So I'm not sure if you can see it if you're using the web interface, but it looks like I think everyone's using Microsoft Teams because I didn't have to invite anyone into the meeting. So anyway, you're all dismissed and have a great
Mr.
day.
Lim?
Yes, go ahead.
Sorry. So are we going to continue going over the class diagrams we submit on Friday as well?
Yes.
Okay. Sounds good.
I want to have everyone have ample opportunity and to develop a deeper understanding of both what the intent of the diagrams are and some of the diagramming syntax of it. You know, what symbols mean what. And so this was actually a valuable exercise in McKinnon's diagram where, yes, exactly, this design is great information, but use a different diagram because this diagram is not meant for what you're trying to convey. So these are all valuable things to learn for review. So I'm glad that we are able to go over this, and I want to keep going over it because this is an area that I think is valuable to have as under your belt, because UML diagramming, again, is a very popular design tool. It's not used by everybody, but a lot. It's very heavily used because it is one of the big standards. Okay, so any other questions?
Yes. Can you hear me? No?
Yes, I can hear you.
Okay. Can we resubmit ours if it now looks pathetic compared to these?
Yes, absolutely.
Okay.
Yeah. Now that you learned some things,
Yep.
please resubmit. Yeah, that'd be great.
All right.
Okay. Any other questions? Okay. Well, have a great day, and we'll be online with you later. Bye-bye.
Goodbye.
Oh, and the person recording, could you stop the recording for some reason? Oh, wait a minute, I can. Here we go.